All right, you ready for some fun math? In this video, we're going to really work to accomplish this learning target. Use properties to simplify expressions. And we're going to have some one variable things that we're working on and some two variables. And remember that a variable is a letter that represents a number. Okay, so here we have one variable, 4 parentheses 6x. So we can use some properties to help us to make sure that this can work. So if I spell this out, it's 4 times 6 times x. That's what I have. Now, I know that the associative property tells me it doesn't matter. When it's all multiplication, it doesn't matter which numbers I associate. So I'm going to switch this to equal 4 times 6 times x. And instead of doing the 6 times x first, I'm going to do these first. So when I do this, it gives me 24 times x, which equals 24x. And we've used the commutative property, or the associative property, I'm sorry. We've used the associative property to help us to see that this can be simplified to be 24x. Okay? Let's do a couple more. So we have 3 times x times 11. Same type of thing here. So we have 3x times 11. That's going to get us 33x. This one is plus. I have an x plus an x plus an x. Well, how many x's do I have? 3 x's. Okay, that's multiplication. You always can take repeated addition and make it into a multiplication. Like if I would have 4 plus 4 plus 4 plus 4 plus 4 plus 4 and go on and on. It's going to be 4 times however many times I do the 4. Okay. Here, we talked about like terms. When you're adding, you have to have like terms that you can add together. I am going to, because of commutative property, I can switch this to be 7x plus x plus 8. So now I have these two next to each other, and if I have 7x here and I have another x here, I have 8x plus 8. Now, I can't get 16x, and the reason why I can't get 16x is because this is 8 times x plus 8. If they were all times, then it would be a different issue. But because there's a multiplication here and addition here, these are not like terms. This is an x, and this is just a number. So that's as far as we can go. Okay? Let's do it with a kind of a story problem. And I have this story problem here, and I have it kind of next to my mantra, keep calm and do math. These we can kind of look at and kind of figure out. Once we get to this, we're like, oh. All right, so let's just keep calm and do math. All right, so I have 3 friends. X admission to the museum. I don't know how much it costs to get in the museum. It costs something. We'll call that X. So once they're in the museum, they want to do the mummy exhibit, and it costs $1 more for that. So for one person to get into the museum and to do the mummy exhibit is going to be X plus 1. So it's the admission plus the $1. Now, and there's 3 friends. So they also have a 4th friend that will pay admission but does not want to go to the mummy exhibit. We want to find the total cost. Okay? So let me find the cost of this first. 3 friends. If I have X plus 1, that's what one person costs. If I do this, then I have the cost of 3 people getting into the museum and getting to the mummy exhibit. So 3x plus 1. Now, I'm going to add a 4th friend. So I need to add 4th friend. He wants admission to the museum, but not the mummy. So he just wants X. He doesn't want the mummy. So I have to add his admission. So now I have 3x plus 1 plus x. I'm going to see if I can get this to where possibly I can simplify it. Now I'm going to use the distributive property here. 3 times x, 3x, plus 3 times 1 is 3 plus x. Now I have things separated by pluses, so I have a term here, I have a term here, I have a term here. Now I'm going to put like terms together. So this is an x and this is an x. 3 x's and just 1 x there, I add those together, I get 4x plus this 3 doesn't have an x, and there's no other just numbers, so this is my answer. So if I want the total cost of 3 friends getting into the museum, going to the mummy exhibit, and a 4th friend just getting into the museum, it's going to be 4 times admission plus $3 more. Okay? Keep calm and do math. Good. All right. Let's look over here. Now, instead of just one variable, let's add a variable. Let's do two variables. Okay? So we have 4. Well, let's come over here. Let's do this one first. 14y plus x plus 22y. Now, I see I have y is a variable, y is a variable, x is a variable. I have 2 variables in here. My variables are x and y, x and y. Now, I'm looking at this, I see this is plus and this is plus. I want to get my y's closer together. So based on the commutative property, it doesn't matter, 14y, these are all plus, I can move this around, plus 22y plus x, okay? And then I can do this first. So because it's all plus, I'm finding my like terms. This is a like term, this is a like term. There are no other things that have x in it. No other x's, that's its own thing. So let me add this up. I get 36y plus x. So this, okay, simplifies to be 36y plus x. It's an equivalent expression, the same. These two are equal. This is just in simple form. Simple form. Okay? Let's see what time it is here. Okay, 8:03. Now let's go over here. Let's look at this distributive property. Now, I want to simplify this. I have 2 variables. I have an x and a y. But I know that with this here, I'm timesing it by this here and timesing it by this here. So it's 4 times 2x plus 4 times y. And let's see what I get. Now, because 4 times 2 times x, those are all multiplication, I can put them all together. 4 times 2 is 8x plus 4 times y, it's going to be 4y, and there is my simple form. So this right here is the same as that right there. They're equivalent expressions. And I just did the distributive property. Okay, I'm going to do one more. This one I'm going to do as a factor. So I'm going to take it from this, from here, and I'm going to take it backwards. Okay? So what I want to do is I want to find the greatest common factor of 27 and 18. 27 and 18. I know that 9 goes into 18, and 9 goes into 27. So I'm going to do 9 here. How many 9s go into 27? 3, and that's 3x, plus, how many 9s go into 18? 2, 2y. So, if I wanted to factor this out, it would be 9 times 3x plus 2y. Okay? All right, one more that I want to do, and then we should be all set. Again, this is a word problem. So we need to stay calm and do math. Okay, I'm going to use this book over here and use this problem. It says this. The farmer market sells fruit baskets. Each fruit basket, so one basket, oops. So basket has three, it tells me this, it has 3 apples and 1 pear. So if I buy a fruit basket, it's going to have 3 apples, 1 pear. Sounds good. Okay, then A represents the cost of the apple. So each apple cost $A, and for the pears, each pear cost P dollars. So my variable is A and my variable is P here. Now let's keep reading on. Write and simplify an expression that represents the total cost of 5 baskets. Okay, so I'm going here. Maybe it's around a holiday. I want to take some fruit baskets to people, and I need 5 of them. So I need 5 baskets. And I want to know the cost of it, and I have to use these variables because this is what I know is the cost. So 1 basket is going to be 3 apples, 3A. So 3 apples times the cost plus 1P. Now, I don't need this 1 in front because anything times 1 is the other number. It's the identity property, and we know about that. Okay, so that equals 1 basket. 1 basket is 3 apples and 1 pear. So 3 times A dollars plus P dollars is going to get me the total cost of 1 basket. But I have 5 baskets. Oops. 5 baskets that I want. So I don't want 1 of these. I want 5 of them. Okay? Now I'm going to use my distributive property to simplify this. Okay? So I go over here. 5 times 3, A, plus 5 times P. Okay? So it's going to be 15A plus 5P. And this will be 5 baskets. The cost of 5 baskets. It's the simpler version to do it this way. I mean, once I find A and P, I could put the cost in here. I could put the cost in here, do this, and then times it by 5. I could do that. But I decided since I only know these variables, I would simplify it here. Then once I find the cost here and the cost here, then I just add the 2 together. Okay? So we're really working to use our properties that we know, commutative, associative, distributive, identity, all of those properties so that we can simplify these equations. Okay, we've talked about vocabulary a lot. Like terms is really a critical part of this. When you get to something, do you have like terms? Okay, and when you're adding them, you can add them together. Well, we're going to go over a lot of this, so we will work tomorrow to keep working on simplifying expressions, and you have to use your properties to help you so that you can understand what you're doing.